I will, with that, get right into this talk. And this is a talk that I have called, over the last year, I suppose, Fast, Cheap, and in Control. And I think that expression, in contrast to the Errol Morris documentary of maybe 10 years ago, Fast, Cheap, and Out of Control, characterizes our work vis-a-vis architectural practice, and that's what I'm going to be talking about tonight, our work vis-a-vis architecture. Not all of the works that you're going to see fit neatly within the category of architecture. We have as Beth explained, we have a kind of alternative mode of practice, and we seek opportunities within that outside of the architectural sandbox. We're doing things that I suppose we're opportunistic, if you call us architects, working in a variety of different types of venues. Aside from the conventional notion of practice being about making buildings or academic research. So tonight I'm going to talk to you about several projects that we have we designed and fabricated, constructed ourselves, and there'll probably be about 10 of them. I used to call, I always show this slide because I think that it characterizes something about what we do. It expresses, and I think that the ambiguity of it is interesting, because I don't, Gaston and I are not particularly dogmatic. We're not particularly, you're not going to hear a manifesto from us. But so the ambiguity of this image is something that we use as a kind of window into looking at the work. But it expresses a sort of, at once, a kind of embrace of both the digital technology, of course, represented by the mouse, and the hammer being, of course, representative of the process of making, but also a deep suspicion and frustration with the kind of abstraction within which the abstract nature of most architectural conception, where conception is valued over execution, and execution is kind of seemingly reduced to second-hand status, or something that's rote or mechanical. In our practice, there's a very tight integration of concepts, computation, and the making of things. These things are in a constant dialogue. So instead of being separated into stages, the conception and execution are integrated into a kind of subtle feedback system, where the physical properties of materials encounter conceptual form, and conceptual form encounters physical material. Thinking, making, visualizing, executing, theory, and praxis go back and forth, hand in hand. So it's a craftsman approach. And I'll probably talk a little bit more about my conceptions of craft. I think it's somewhat different than the conventional or the kind of the popular notion of craft, which is a kind of degraded notion of craft, a kind of the craftsman is viewed as a kind of second-class kind of maker. That's not how we think. This image represents two different tendencies in our approach. The left being an image of a trophy that Gaston worked on when he worked at Gary Partners for 10 years as the kind of fabrication guru there. And the right being a set that I designed in collaboration with a production designer named Virginia Lee about 10, 12 years ago for an Audi commercial. These two images represent very different approaches to design. They're not even really comparable. but they come together in our in Ball-Nogues. The left being the result of a process that involves the interrogation of material to yield form, and working with material properties to explore formal potential, and then the right being something that is that's actually a set, so that's about this thick, that's purely optical, that is about the reflecting light. It's about storytelling and image making. So it's these two tendencies that come together with Ball-Nogues: the craftsperson, a craft mentality, and an image-making mentality. And also, with respect to production design, set design, it is the logistics of that practice that has made its way into our work. We couldn't do what we do without me having been very practiced in the making of things that last for very short amounts of time. That comes from, as I've said, movie sets and sets for commercials. Our studio is not we don't like to call it an office. I get a little uncomfortable when people ask me if they can come to my office. If this is our office, I guess. There is a space up there, which is a kind of a mezzanine where there's some computers and a coffee maker. And then down here is a full fabrication shop, probably superior to what you would see in most universities, which I think is a significant thing to mention. So there's a very short distance between the kind of napkin sketch and the working directly with materials. Very short supply chain, I suppose. Gaston comes from a hot rodding background. And I think that it's interesting to note that that hot rod culture it's been quite important and prominent part of Los Angeles cultural production. And I think that has to do with several things. Typically, people associate it with the fact that there's a lot of freeways, and I think that that's probably true. But there's also another significant fact, which is that Los Angeles is a major center of aerospace design and fabrication, automotive design and fabrication, as well as a place that's sunny, warm, and has cheap space to work in. All of those things combine to create a climate in which one can be a tinkerer, if you will, and work with materials to yield things like hot rods. And the hot rod in particular is interesting because it's a kind of making something with the least possible means. It is also a kind of do-it-yourself culture, which is definitely something that Ball-Nogues embraces. We're not particularly reverent, I guess, if you will, of the academic culture. We're part of it to some degree, but we have tended to kind of try to move outside of it. So it's this kind of do-it-yourself ethos that makes its way into the work on a very shoestring budget. I talked about production design in film. We do something I would term design of production, not at all to be confused with production design. By design of production, I mean the design of the factory, the design of the production scheme prior to the design of objects. We don't take a kind of, I like this shape approach, I guess you could say. This image is from one of Henry Ford's factories, which, if you know much about the history, the factory had to be conceived before the car could really be fleshed out. It was Ford's innovation in terms of the factory production, his intuitions about the assembly line, which enabled him to achieve the economies of scale in which he could make a car. So why is that important? It puts us in a position of power, which is something that young architects, young designers, even artists have not been in the last 20 years, because the methods, means of production are in the hands of someone else. We own the means of production, we own the methods of production, and that means that you have to come to us to get it done. Also, I think significant to note is that we've designed our career as well. Kind of not really working within the conventional opportunities that we associate with architecture. Our work began in 2004 with this project, Maximilian Schell, that was done with approximately $5,000 in budget. And without getting too deeply into this project, what it really did was codified an approach to design and to making that has followed us throughout the past 7 years. The work was really an attempt to simultaneously grapple with an interest that we had at the time in something that's now probably fairly common, the power copy, and over a minimal surface. How could we explore that concept of kind of the non-standard part without expending a tremendous amount of money on fabrication? Well, the most obvious to us at the time was we would do it in tension. So it was a matter of matching that theory with the appropriate methods of production, in this case sailmaking, that enabled us to do this. And the result, as we kind of explored it further, yielded this, this kind of mandala pattern that kind of stains light itself and projects it onto the ground, creating a kind of pocket park in an urban vacant lot in Silver Lake region of Los Angeles. That thinking, that project really propelled us into the PS1 competition in 2007, where we were asked to, if you don't know much about it, it is a competition sponsored by MoMA to make this space into a party space for a summer music series that hosts something like 5,000 people, many of whom are heavily intoxicated. And so we thought of this as a kind of prison yard, and we decided that we would take the method of production, the design that we had elaborated on, or that we had developed with the Maximilian Schell project, the previous project, and we would kind of put it on steroids and take it further, make it happen faster, make it happen bigger, make it be stronger, in order to yield an environment which would have produced both shade for the summer, as well as seating, as well as water. So the seating in this case was a series of hammocks which mimics the structural concept of this canopy above, which was made of like something like 1,300 separate units of tinted mylar, and then supported by common utility poles arranged in a tripod fashion. And then the water was like actually sprinklers that would spray on the top of these and kind of rain down onto this. And it's a little bit like a circus, which I thought was an interesting juxtaposition to within this kind of austere, like I said, Frederick Fisher's sort of prison yard, and also the kind of self-seriousness of the high culture business that is PS1 and MoMA. So I'm going to show you several what I would call projects, but the projects happen across several incarnations, or kind of what we would conventionally call projects. Kind of the meta project is incarnated in several smaller projects. So there's 5 of them, and these are ongoing, and each would be a fairly good example of this integration of concept, computation, and fabrication. So rather than trying to solve architectural problems outright in each of these projects, I think each one marks the evolution of a tool and a method whose immediate value is not particularly clear for architecture. We think of these, if you think about this as architecture, we think of them as almost creating a kind of architectural technology shelf, which is something that Motorola developed in the 1990s as a way of taking ideas that didn't really necessarily have any immediate value, kind of putting them on the back burner, putting them on a shelf, and then dusting them off down the road if they saw something that could potentially be of value. So there's 5 of them. Expressed through the Ripcurl Canyon project is something we call continuous micro offset modular stacking. Each of these titles is what I call a 5-minute title, meaning it's a kind of throwaway, kind of academic sounding title. Feathered Edge, which is part of a meta project that I would call suspensions or gaseous pochés. Tablecloth is part of something called cross-manufacturing or the design of disappearance. The elastic plastic sponge, I just came up with this one a couple weeks ago, we call limber structures. Cradle and talus dome is about sphere packing as well as cross-manufacturing. The first, the continuous micro offset modular stacking, I hope none of you ever use that expression because it's almost embarrassing for me to say it, but I had to come up with a name. First took hold in a 2006 project that when we were asked by Frank Gehry to create an environment for his Tiffany jewelry launch on Rodeo Drive in Los Angeles. This is an event design. This was what ultimately became a wall with a series of windows in it. Each of those housing a live model naked model wearing Gehry's jewelry. So how can we create a kind of shared memory for visitors to this event? We were asking ourselves. And then how do we take this kind of idea that Tiffany had been exploring, which is they're calling the body as landscape, as their advertising catch concept, and formalize it in the form of an environment? And then how do we create an homage to Gehry without becoming trite, and also blending Gehry with, which is kind of a rough aesthetic, a kind of a crafty aesthetic with the kind of refinement and tradition of Tiffany. We started with this as the kind of pretext, which is one of Gehry's, these are called Easy Edges chairs, and thought this is a kind of die-cut cardboard extrusion, and thought, well, why don't we begin to twist that and manipulate that in the manner of a deck of cards. Die cutting, if you don't know much about it, is a kind of cookie cutter, which that's the cookie cutter, cuts impressions of cardboard and other sheet goods at a very rapid clip. So this is actually the pattern. So you get maybe 6, these are 2 different dies. You get something like 6 parts coming out of one impression. It's a matter of bringing those parts to the workplace, dividing them up, and then exploring what they can do formally by shifting them in relationship to one another. So that exploration, which was fairly successful at the Tiffany project, then became again in the same kind of way thinking that we employed with the moving from Maximilian Schell to PS1. let's kind of think about making this more robust, making this more architectural. So we thought, let's make, rather than being a wall, let's turn it into a landscape. At Rice Gallery in Houston, this project was called Ripcurl Canyon. The goal was to create a kind of space of exploration within the gallery context. This is an art gallery that it focuses almost exclusively on installation, and we sought to kind of extend the casual atmosphere of the campus into the gallery, and then also create a kind of western landscape within the swampy flats of Houston. If you've been there, it is swampy and flat and wet. Again, this time taking this idea of the twist of the stack, exemplified in this model conceptually. There's the entryway, there's a vestibule, and then there's a walled gallery. That we would create this kind of plateau in the back with these 5 stacks or ribbons, which would twist and break apart to form a kind of canyon and a plateau within the gallery. We then, after this was conceptualized, we then went immediately into constructing a parametric model, which at the time there wasn't a lot of tools available to do that. There was no Grasshopper. We did it in a program called Top Solid, if you want to talk about software, which is a mechanical engineering software. So we adapted that to make it a model in which we could explore the formal potential of stacking these specific pieces of cardboard and twisting them. There's the model. This is all kind of old news by now, but you're making a model that is essentially a linked set of sets of data that enable you to explore a range of possibilities. So thus, the roots in the mechanical engineering business, where you can actually make an operating piece of equipment that you can kind of test a prototype in the virtual world, because all of the linkages come together and talk to each other. And then taking that idea further, where each of these ribbons or each of these stacks spoke to the next one in a kind of manner that a kind of tectonic plates would push against one another. The process was in direct the digital process in direct feedback with this exploratory process of making mock-ups in our studio, our then studio in Echo Park. So we're looking at the twist in the cardboard, the amount of twist that one could put over a distance in one of the stacks, and the amount of ripple, looking at the ways to attach it to itself, so that it could be feasibly achieved within a 3-week installation time. So we're constantly balancing the installation logistics against the production methods. This is the green is the kind of aqua is the cardboard, and then this is the kind of armature that it sat on. Armature didn't really support the cardboard itself as much as it just kind of elevating it. So I suppose technically you could call this a semi-monocoque. And so in 3 weeks we have to go from this locating. This is the only measuring that we had to do, was locating these verticals, to installation of these ribs, to finalization of the ribs, to the application of the cardboard. Blah, blah, blah. You see a lot of these kinds of images these days. There's the system on the ground. That's, again, the only measuring. As we were doing this, we kind of noticed that we were learning a tremendous amount from putting it together ourselves. We had a few students help. And it's funny that Kim Davenport, the director of the Rice Gallery, says to me, "You guys need to write a book that's called Contempt for Labor," because she thought it was very interesting to watch our process, because labor in the minds of so many designers and artists who had been through her gallery of which is a very impressive cadre, have no interest in the production process whatsoever. Production is something that's kind of lesser than, it's something that's kind of rote, it's something that comes after conceptualization. We take an inverse approach, as I said. The integration of labor and the understanding of craft into the conception of the project is paramount. That's a picture of me up there. So this was put together with about 5 people over 3 weeks. It weighed 8 tons. And it looked exactly like we envisioned it. And was, in contrast to the Tiffany piece, was suitable for climbing, walking, exploring. And then the underside had a very different conception than the top, which was more of a kind of a space for where one could hang out. There's a lot of different activities happened in here. Classes happened in here. The opening happened underneath this. You'd go in there on a given day and people would be smooching or listening to the music or writing or what have you. So that leads us to another set of projects, and this is probably the most longest ongoing set of projects that we've done. Not to say that we won't pick back up on the cardboard stuff. It's called Suspensions or Gaseous Pochés, and is expressed through these 2 projects, the top being one we did in Chicago in 2008 called Unseen Current, and then the one below being Feathered Edge that was done at the Museum of Contemporary Art in Los Angeles in 2009. We're still working with this method. So what this comes out of is an interest in working with a variable unit, which was something that we'd done in the Maximilian Schell project, and reducing the variable unit down to its minimal expression, which would be a string. So you have one variable within the unit, which is length. Length, and then it's the relative location of the unit, the ends of the unit in space. So if you take a piece of string and you hang it between my 2 fingers, you can vary its length, but then you can also vary its relative position, like this. So using that set of parameters for the production of these units, we set about making these projects, and we realized that it would produce a kind of space that would have a very strong sculptural presence, but would almost be invisible, would be almost nothing. Thus the term gaseous pochés. So it's about kind of modulating a space with a kind of atmosphere, not an atmosphere, literally with a kind of atmosphere, not so much an atmosphere in terms of feeling, but atmosphere in terms of like the physical properties of the stuff that's within the space. So we're making a kind of an architecture without objects, without figure, if you will. And the thinking about this came out of being confronted with an invitation to produce something in Chicago while living in Los Angeles that was to cost less than $2,000 when we were barely making our rent. So this is the space. So we thought, well, how could we begin to fill this space? And thus came the exploration of the variable unit as the string as variable unit, the catenary as variable unit. We had seen these explorations by Friato that he had done in the 40s and the 50s, which were used not so much to create this kind of atmosphere or to fill space, to fill volume, but more to optimize structure. He would hang the catenary and then solidify it and then flip it over as a kind of analog computing method for producing thin shell concrete structures. I saw this one, and I thought, well, each of these is a different unit. What if we expanded that out into three-dimensional space and then changed them all as a kind of a whole? We could control them in relation to one another. And we also started thinking about, well, what would this mean in terms of color? We thought, let's bring the atmosphere of Los Angeles, which is a cerulean blue, down to a smoggy, rusty orange, into the skies of Chicago. And our first exploration of this was done through in analog form. We built this is a model which was kind of a large plywood box with 500 holes drilled in the sides. And by hand, meticulously, we studied how we could create a sense of unity between these catenaries, but each one would be different. We quickly learned, and we had actually predicted, that this was going to be an extraordinarily time-consuming process. So we would have to develop software which would enable us to design with the catenary as a unit. And so we worked with a software developer to develop a kind of parametric software system which would enable us to specify the launch points of the catenaries and the low points of the catenaries, and then begin to kind of sculpt them in three-dimensional space. And the software can yield a kind of infinite variety of spatial configurations, and then output the data for cutting, because now we're talking about 2,500 strings, each of them located at a different place on the wall. That's the wall, the launch points, which were defined by a big banner that was printed, like a big billboard print. That's the CNC process. But we decided we were going to cut this by hand. There's no other tool available to do the cutting. So we had to develop a kind of human machine where we laid out tape measures. We had data that was on little Avery stickers for each of the individual strings. We measured them and then spooled them up and then cataloged them for hanging on this banner on the wall. There you can see the spools. The process was, in fact, inspired by the latch hook rug. It's amazing the kind of technologies you can find in something that you don't normally associate with like high design. So Gaston's like asking me, well, how are we going to attach this to the wall, and how will we know where it is? And I was like, have you ever seen a latch hook rug? And we could essentially print this pattern with a large format printer, and then weave the individual strings through their respective locations on the map on the wall, if you will. This yields a kind of digitally aided craft or digitally aided handicraft. I would associate this kind of stuff with handicraft, not with craft in the sense that we're talking about craft. Handicraft being something that's a kind of the kind of a lowbrow, demeaned, kind of rote kind of craft that you that doesn't require much thinking, versus a kind of a more expansive notion of craft. And if you're interested in that, I would suggest you read a book by Richard Sinnott called The Craftsman, or perhaps the theorist Howard Rosati's notions of craft, where they expand craft into becoming a kind of medium for exploration in its own right, as distinct from art, as distinct from design. Very important. So we're latching these through the mesh banner on the wall, each of these made by the printer. And then finally we get the result, which is a kind of three-dimensional aerosol painting, inhabitable aerosol painting. And the coloration, transformation of color across the space through a process of dithering. So alternation of we're introducing a few blues here, and then we get more and more and more and more and more, and ultimately across the space we're into blue. So it works like an aerosol in the sense that an aerosol is projecting particles to create color pattern and to blend color. In this case, the particles are actually the strings themselves hanging in space. This one particularly looks like an aerosol painting that kind of airbrushed out the background, which I'm quite fond of, which actually led to the conception of this, suspensions. Suspension in chemistry terms is a suspension. It's something where there is a particle which is floating within a liquid or a medium, and the particles hover and do not sink within that medium. Aerosols are suspensions. Blood is a suspension. Milk is a suspension. But then also it's a double entendre in the sense that the piece is actually suspended. About this time, Gaston, the custom car guy, says to me, I think that we could develop a machine which would help automate the process of producing these projects. We were very pleased with what we had produced in Chicago, and he said we could make a machine which would cut the string to individual lengths based on numerical output from the computer, and then we could also it could also spray paint the string in discrete locations based on numerical data, and consequently this would expand the potential of this suspension and gaseous poché exploration to include color, which was actually occupied individual locations within an array of string. So we set about doing this thing, which we called the Installator 1 with the variable information atomizing module. It was a very lengthy exploratory process of making this. We first kind of premiered it at the Venice Biennale in 2008. All of these drawings were produced after the machine was made. So the machine was very much about a kind of, I mentioned tinkering, was done through a process of tinkering, done through kind of exploring how you could rig this thing to propel string through a series of pinching rollers and make it cut and hold it into place and so forth. This guy should go. So this video shows a little bit of it in operation. So you have 4 off-the-shelf airbrushes. We're not interested in reinventing the airbrush. This thing uses a kind of a hybrid or combination of readily available parts as well as custom fabricated parts. So the airbrushes come from somebody who makes airbrushes very, very well. The stepper motor, which is inside of this, comes from somebody who makes stepper motors very, very well. And it's all driven by a motor controller, an Arduino. But it's the combination of the parts that yields the machine. Each of these is driven by a solenoid. These are the airbrushes. So we have to design this apparatus that holds them in place. And the operation of this is very, this isn't like going to Home Depot and buying a table saw and opening up the table saw and using it. This is a machine that requires a little bit of knowledge in order to operate. But I always like to tell people that if we were to make this a marketable item, it would probably be the difference between spending, maybe 6 months and, $20,000 on its development versus spending like $200,000 to make it more user-friendly. It's that last 20% of a machine that enables anybody to use it that makes it very, very costly oftentimes. So what that enables us to do is to make these arrays of strings, these gaseous pochés, into something akin to ikat, which is a textile making process that a lot of people would say comes from Central Asia. In ikat, these are ikats. The weft yarns are placed into or the warp yarns placed into a loom, and then they're marked out where you want to color them. They're then bundled and taken out of the loom and dyed, and then put back into the loom, and the warp yarns are woven through them, or the weft yarns are woven through them, to yield very, very bright kind of patterns, designs. It's a little bit like composing with 8-bit color graphics. If any of you guys, I know all you guys had Mac 2s, right? All you students back in the day. 8-bit doesn't mean anything. Okay. So this led to Feathered Edge, which was the kind of the premiere of the installator, and Feathered Edge commissioned by Mocha in LA, part of a series of installations that until the austerity measures at Mocha laid Brooke off, Brooke Hodge, the curator, that were to explore the convergence of computation and craft. What does that mean? The advent of computation in design and its intersection with craft. So the title Feathered Edge really comes from several places, one being a kind of softening of the rigid architectural setting by the presence of this array of strings, a kind of formless, almost a figureless kind of architectural intervention. And then, but also the softening of the boundaries between conventional notions of craft and new forms of craft that have evolved as a result of digital technologies. And also painting and printmaking. We chose a set of colors for this, which were deliberately in reference to printmaking, CMYK, cyan, magenta, and yellow and black, because this is a little bit like a printing process. Our first exploration of in the digital, in the computer, we looked at painting the string using recognizable figures, in this case, big hovering spheres, and where the spheres of the different colors intersected, they would yield the first order derivative color. So where a blue and a yellow intersect, you get a green. And that's not because we wanted that necessarily, or we were interested in green. That's because when you spray we have 4 colors that we can work with on the installator, because it has 4 airbrushes. So when you mix a blue with a yellow, you get green. Now, we first thought that we wanted to make this kind of these recognizable forms in it, and then we eventually abandoned that. We thought it was a little bit too simplistic, a little bit too diagrammatic, a little bit too didactic, and we ended up opting for which I won't go into too much, an algorithmic approach to the distribution of color. The space, as you'll note in this drawing, is a kind of skylight that projects up into above a 14-foot floor. So our piece is kind of hanging off the walls of the skylight and the ceiling of the skylight and draping down almost like a kind of atmosphere that's pouring from the sky. And the algorithmic approach to the distribution of color came out of an interest in making the color resemble light itself, so that when you have a lot of lights mounted in here, you have windows up here, so the color has this kind of streaky quality, this kind of almost like a Jacob's ladder that you see in when you have light coming through a foggy a foggy environment. And so we produced that system for exploring color, and then we actually tried to formalize what would that color look like if you were to make it a solid. This was the shape, so you see the kind of solid shape of the color, which is kind of removed from the array of strings. It's an interesting kind of relationship. The title also, I could say, refers to this because it looks like Farrah Fawcett's hair from the 70s. Again, you guys probably weren't around. You guys were. You were, right? Okay, so moving on. The next, this is the ceiling from which we're hanging. So it's like having a three-dimensional canvas. We're kind of using architectural thinking to yield a system which becomes a kind of medium, I think. And you'll notice that the color, one of the things we really aimed for with the color was that it would hover, it would be somewhere between a kind of recognizable object with a clear geometry and a kind of nebula, kind of amorphous nebulousness, if you will. So as you move around the board, the colors kind of snaps into focus at certain points, and at other times blurs and softens. So you can see like kind of streaks of magenta, and then it will, as we move around it from another vantage point, it will blur out to become more cloud-like. And again, this time we're working with getting the strings to kind of intersect, to kind of cross one another. And we took this idea again further into a more permanent architectural setting, this time a project called Drop-In Distraction, which is a commissioned public artwork which integrated with an existing ceiling in a building permit office in Los Angeles, and then to a Binali in Bordeaux, where we went back to that concept of making something figural and representational within the string. In this case, we're hanging from this is a 19th century warehouse that's become a contemporary art museum, hanging from underneath the arches, but then projecting into that array of strings, we make a kind of a brick wall, which echoes the pattern of stone within the building itself. So that's actually a three-dimensional pattern of stone within the array. So this idea of doing more figural things took hold again in this project at the Indianapolis Museum of Art. This is a kind of, this project was called Gravity's Loom, and we were asked to make an installation within this kind of rather unremarkable, architecturally unremarkable entry vestibule at the museum. And rather than thinking of the strings as being a kind of pochette, we thought of them more as a surface which spiraled around, attached to a kind of cornice line, if you will, within the oval space. And then thinking about the color in this case as being in reference to a Baroque architectural dome, in this case the most foo-foo Baroque architectural dome that we could find, which was the Steinhausen Church in Germany. So we took this, abstracted it into that, again using the CMYK colors and its first order derivatives, yielded something that I thought looked a little bit like an MRI or like a brain scan. And in this, a little bit like a Peter Max drawing. Again, you guys, Peter Max? Yellow Submarine? kind of psychedelic. So I love this idea of like mixing the kind of the computational with the 60s psychedelic kind of pop artist with the Baroque, and seeing where it lands, the love child of those three things. But we did think of the building as being in the lineage of Baroque architecture, as an oval, a kind of a bad Baroque, 20th century kind of cheap version of it. And we will be moving into another project in this vein into the new Bradley West Terminal Los Angeles International Airport that we call Air Garden. We think of how could this be used as a permanent piece of architecture, or a permanent aspect of an architectural environment? Well, we've all been in airports. They're a bit like, we kind of thought of it as a kind of a city, and if this is a city, that's almost connected to this big network of cities across the world. It kind of expresses itself as a kind of monocultural urbanism within the airport, which is basically shopping. We thought, well, let's make this kind of garden within that environment. Suspended from, well, this is an old version, but it will be suspended from 6 places. And whereas we were using about 30,000 linear feet in the project in Chicago, well, this will be approaching 1 million linear feet of material. We don't typically make elaborate animations or presentations. We find that the amount of energy that has to be devoted to making these makes it kind of unfeasible economically. So we're fortunate in the sense that most of our these public commissions that we're doing, public art commissions, don't have that, we've been kind of pre-vetted for these projects, so we don't have that kind of degree of salesmanship that has to go into them in the form of, Maya renderings and elaborate lighting and so forth. I'll show this slide. I wasn't going to show it, but I'm going to show it. That's Frank Zappa. Do you guys know who Frank Zappa is? Yeah, you guys do. Okay, so Frank Zappa was working in the musical avant-garde in the early 1970s, in an environment where the score had become one of the most contested things in music. It was there was a fascination with how score could be interpreted as music. And so you have people like Lamont Young who are producing these scores that are almost works of art in and of themselves. Zappa, who's kind of got a foot in this world, but also has a foot in the pop music world, wants nothing to do with it, and says that it's a little bit like food. And if you're into food, you don't eat the recipe of the food; you eat the food itself. And so the recipe being the score. And I think that the music is actually the vibration of sound waves hitting your eardrums. That was his conception of music, not Lamont Young's, which was more of a conceptual thing that was based on the interpretation of the score. So I think that that's an interesting quote because while I'm showing you a lot of recipe, I don't believe that this should be what you should be eating. You should be eating the work itself, but unfortunately we're here and the work is in other cities. In 2008 or 9, we started thinking about how our work, we'd produced something like 10 installations, and we started thinking again like architects, how could we what does this mean with respect to sustainability? What does it mean that there's this kind of growing trend within the architectural world to make these things and then throw them away? So we sought through these two projects to address that topic by making an installation where the disappearance of the installation was integral to the design. That the conception of the installation was more than its formal outcome hanging within a space, but was also its disassembly and distribution within the culture after its life as an installation was over. We called that cross-manufacturing, in that we were making componentry that could be double as a building component, but also be a useful object in its own right, which would have value in its own right, without any modification after the installation was over. I like the term design of disappearance better than cross-manufacturing at this point. But the first one was at the Shenzhen Biennale, where we collaborated with American Apparel, and they gave us 12,000 articles of clothing, which we then hung using our catenary maker in this skylight space. The clothes could then, after the Biennale, it's kind of arrayed in this kind of corny dragon shape. Again, we're in China. These could be plucked and taken home by the residents of Shenzhen, a kind of gift to them. And then more sophisticated version of that is this project called Tablecloth, was done at UCLA, where each component is actually a functioning table, each of which is different than all the others in the installation. This was to double as a performance space. So this is a kind of in-the-round theater and an acoustical reflector or a diffusion device behind the performance, and then the audience can gather around it in different configurations. We would start with a relaxed draped surface and then divide that into a distribution of points that approximately fell within the size of a sheet of plywood, and then divide that into triangles, and then divide that into ovals, and then voila, you have this complex fabric, if you will. Each of the connection points is then flexible. And it's kind of draping, again, kind of tapestry. And when people ask me, like, physically what it's like, I'd say it's probably a bit like this Paco Rabanne dress from 1963, using little plates. This is the only construction drawing for it. Hanging from a big kind of shower curtain. Each one of these tables is individually labeled, like in the manner of maybe a Herman Miller furniture back in the day, where they all had individual numbers. So there's conceptually thinking about the making of an installation as being a way of yielding a whole, a unique set of designer objects. There you go, tables. There's one of the unique identifying labels. So it deals with sustainability on the terms of an installation, which are different than a building. It's more important that this thing be something that can be useful after it's broken down than it be something that comes from within 500 miles or it uses low energy to produce, a low amount of energy to produce it, and so on and so forth. So it's a different set of metrics that I think go into installation sustainability versus building sustainability. And of course, it was a musical event, which is something that's also, I think, becoming more and more important in our work, is the kind of relational aesthetic aspect of it, in that it produces a kind of event, social engagement. Then afterwards, just take it home, put it in your Schindler house. I'm not going to talk about this because we only have about 5 more minutes. I'll talk about this. Limber structures. Beth mentioned the Coachella project, and we worked with Coachella Valley Music Festival, the big rock indie music festival in near Palm Springs, to create a class where the festival would fund a pavilion by SciArc students. And so we began this project with, it was very open-ended. We had 12 students, and they were not given any mandate other than to make something within 7 weeks, to design something and develop something, prove its feasibility, and prove that it could be done with a $15,000 budget. So it's kind of an inversion of the conventional kind of architecture studio where you're given kind of free rein in terms of budget and production, but you're given very strict kind of mandates in terms of square footage, and this is where it's located, and so on and so forth. In this case, there's no mandate in terms of what it's got to be. It could function any way you want it to be. It could be a floor. It could be a, it could be a painting. As long as it's a good idea. So we had them look at the history of the festival, going all the way back to the Bacchanal, and then looking at festival environments today as being almost like miniature temporary cities. The left is the Pinkpop Festival in Holland, which produces probably as much waste as a city in a given day. And then the right is the Glastonbury Festival in England. And then Coachella, which is the cleanest festival, actually, if you've ever been. So the students, you have 7 groups studying things, start launching out on this kind of, these explorations of how could they produce this pavilion. No mandate. These guys are working with tube. These guys are working with this idea of what we call the big honeycomb. And the big honeycomb could be produced by big tubes of plastic that are kind of attached like a honeycomb and then bent into shape. This was quite promising. Ben Lloyd Goldstein produced this thing that we called the gem by studying how to bend PVC tubing. And that was the project that we kind of thought was the strongest, but it didn't really have an idea about how it could be integrated into an overall structure. And so the idea was to kind of integrate it to kind of combine it with the big honeycomb idea. So you take these individual cells here, made out of PVC tube about this big, and you combine them into a flexible structure, a limber structure, and then you bend it into shape. This conception came after the exploration, not before the exploration. It's important, I think, for students to note. So the idea is you could bend it into shape. So we went out to the desert. We set up camp. We made bending jigs. We bent them into these units. Here's one of them. We arrayed them into a kind of ribbon, and then we lifted it into shape using cranes to give us this. Just to give you a sense of its material, the feeling of this. It's not something that you can design with software. It's not something you can design with even a model. It has to be done one-to-one. It has to be made at full scale, bending the material, testing the material constantly to see what it's capable of doing. We lost it again. I think that's a sign that I've gone on way too long.